Okay, we'll start off. Our respected coordinator of the center, the Biodiversity Research Center, and head of the Department of Environmental Science, Professor O.P. Tripathi, the Comptroller of Examination of Mizoram University, Professor Tulanga sir, and our Dean, Professor U.K. Sahu, and the HOD of Forestry Department, Professor Upadhyay, Kalidas Upadhyay. Good afternoon to you all. And Dr. Chris, who's from our expert and resource person from Italy, and the participants from Europe, very warm good morning to you all. And for the people from the Far East, I think some of them are there from Malaysia. So I think it's probably, I would wish them good evening. So I would welcome you all to this webinar, and we're very glad to have you with us in this platform to celebrate the International Biological Diversity Day, which was happened to fall on a Sunday, which was yesterday. But we would want to do the celebrations on Monday, and on the theme of building a shared future for all life. This is a day which also reminds us that the extent which we depend on biodiversity, and we should and the need to conserve it. Okay, before we go to a talk, I'll just give you a brief build-up into this before we give the platform to Dr. Chris. Just briefly about why this webinar has been organized. And yeah, despite the efforts we have been constantly giving into checking our forest loss and the loss of biodiversity, we are constantly bombarded with news that, in fact, the loss, the reduction goes on unabated, and which is a concern for us. And just to give you some basic statistics, that over the past 3 decades, we have lost about 0.24, roughly 0.20 billion hectares of forest cover, and along with it, the biodiversity which it carries. And sadly, this will go on if drastic measures not taken up. And often we are also lectured on the repercussions of what this will have. And what is more worrying is that sometimes the activities in one part of the globe has an overall global effect. It doesn't mean, it's not a localized effect, but it affects the entire globe. So the question now arises, how can we all have a shared future if such trend continues? So perhaps one way for doing this is to start at our own backyard and take care of environment, and creating a repository of biodiversity in our own backyard. So, or maybe on our man-made landscape. So in that way, we can somehow protect the local biodiversity. And I think we have an expert on this, and Dr. Chris from the Alliance of Biodiversity International and CIAT, the Center for Agriculture, International Center for Tropical Agriculture, who would talk more elaborately on the subject. And he will speak on the topic exploring the role of tree biodiversity in resilient agroforest landscapes, and also relate his personal experiences from where perhaps we can learn lessons for creating a better environment, which indeed we can have a shared future for all life. But before I give way to Dr. Chris, I would like to briefly share some information regarding Dr. Chris. So he is basically a tropical forest ecologist and geneticist who has been working for 20 years on trees, their ecology, and the importance of forest-centric resources for resilient landscape restoration. He has a PhD from the Edinburgh University of Edinburgh, UK, in conservation genetics. And he joined the CGIAR, which is the consultative group on international agricultural research, in 2017, leading a transdisciplinary research team working on conservation and sustainable use of socio-economically and ecologically important trees and the seed systems. So currently, he is the principal scientist at the Alliance of Biodiversity International and CIAT, and holds a joint appointment as a group leader in the applied molecular ecology, the Department of Environmental Science, ETH, Zurich, Switzerland. He also leads the research across Southeast Asia, Latin America, and Africa. And he's leading the restoration work in the Nature Positive Initiative 1 of CGIAR. So with this background, I'm very sure that we are lucky to have to be an audience to such a dynamic expert and scientist. And I'm sure we will have lots to learn from his vast knowledge and experiences that he has to offer. So I give the platform to Dr. Chris. Please, sir. Thank you.
Thank you, Dr. Lingdo, and thank you very much. I'm really honored to have the invitation. It's a great privilege to be able to talk to everyone today and to see so many people connecting online. It's I don't take for granted that people are taking the time to listen, and I very much hope this is a two-way process of interaction, and we have time for some discussion during this 1 hour session. What I would like to do is to split the time into two sections, and first explore a bit the importance of tree biodiversity and how its role can be used in resilient landscapes. And then I'll talk more in detail about some of the recent research that my colleagues and I within the CGIAR and ETH Zurich have been doing in the relationship to this. But before I do that, I thought it was first useful to give a little bit of a background of myself and motivation to why I'm where I am now today. And start by reminding everyone that since I was a very small child, I've had the great privilege of being able to interact with trees and forests growing up in a rural English environment, and always loved climbing trees and playing in forest. And that led me to an early career in arboriculture, where my first job after finishing my high school was to work pruning and maintaining trees. I then went on to a career working really in the reproductive ecology of trees, and I spent the last 20 years studying their reproductive ecology, their conservation, and how we can better understand their contribution to resilient tropical forest landscapes. I've also been trying to inspire my children, and I've had the privilege to share with them some of my work. And here's my children some 5 years ago now, where we were working in the Bornean rainforest and they joined on field work there. So with that background, I think it's worth taking a global perspective on the role of trees and planetary well-being, and reminding everyone the extent to which we not only are privileged to have trees on our planet, but how we've impacted on them since humans have become so dominant as a species. It's estimated that we've got some 3.4 trillion trees on the planet now, which equates to about 400 trees per person. And I don't think I need to remind this audience of the importance in delivering all of the ecological benefits and social benefits that trees have to each and one of us in terms of clean air, water, biodiversity, well-being. And we're losing these at about 10 billion trees per year still through deforestation, which means in 150 years from now, we'll have less than 50% of the trees on our planet if we don't change the way we manage landscapes and manage the way we interact with forests and trees in agriculture. Putting that in the context of agriculture, we know that agriculture contributes about 80% of global deforestation, 37% of greenhouse gas emissions, and 86% of species coexistence. And within the CGIAR, our latest initiative on nature positive solutions in shifting agri-food systems is really trying to address this curve in which agriculture has continually led to a decline in biodiversity across all organisms and genetic diversity, but changing that so agriculture becomes a positive contribution to shifting the reverse and full recovery of biodiversity. And my own interest in this relationship is really in how trees can contribute to reversing that curve in species recovery through agriculture and land degradation recovery. So really, we are faced globally with a biodiversity crisis, the climate crisis, and a global health crisis, which is not just about food insecurity and being able access to a nutritional diets, but also eating the wrong foods that are leading to other health conditions. And I would argue that trees play a critical role in addressing all of these crises. In addition to that, we've recently been faced with the global pandemic, and we know that the relationship between our interactions with the environment are critical to how we manage and avoid continual pandemics as well. So including the resilience of society to these kind of sudden shocks biodiversity is fundamental. If we look at recent analysis that looks at the impacts of the food we consume and planetary health, there was an important publication, the Lancet report in 2019, and some key outcomes from that report were if we are to shift to more sustainable and healthy diets, we need to increase our consumption of nuts, fruit and vegetables and pulses, and including an increase of 200 grams, a consumption of 200 grams of fruit and 50 grams of nuts per day in a healthy flexitarian diet. And of course, trees will be critical to that dietary change if we're going to transition to less meat and more plant-based diets that are both healthy for people and healthy for the planet. Placing that in the context of past agricultural activities that we know have led to significant land degradation, from an economic perspective, we know that total land degradation from unsustainable agriculture costs about 10% of global GDP at about $7.5 trillion. But reversing that trend through alternative restoration and improved agricultural practices has great opportunities, with potential estimated benefits of about $84 billion. And restoration, particularly using nature positive solutions, can contribute to reducing poverty, improving food security, greater health and well-being through interaction with the natural environment and better air quality, better diets, improved gender equality through more equitable value chains, and of course, addressing climate change and improved biodiversity. So all of these 6 SDGs are really very relevant to restoration and the role of trees in resilient landscapes. In addition to just looking at the broad restoration framework, not just restoration of forests, but transitioning agricultural systems using agroecology opportunities is really an important strategy of restoring degraded lands and enabling restoration and agroecological approaches to not only address biodiversity conservation, but also increasing the positive benefits to environment through different agricultural practices. And I've put this slide up here, which comes from a recent paper that I co-authored with colleagues led by Sarah Jones, also from the Alliance, that will be published in Sustainability Science, which really shows different ways in which research strategies can catalyze agroecological transitions, particularly in low and middle income countries. And I just am highlighting here the importance of trees, not only fruit trees, but also trees for improving soil health and increasing biodiversity, for integration into these transitions of these agroecological systems across multiple countries. Here we're showing examples from family farms in Cuba, smallholders in Burkina Faso, and family farms in Vietnam and Brazilian agroecological context. I want to give 2 short case studies, the first of which I think is really useful for thinking about how valuable tree biodiversity can be for society. And this gentleman here is a farmer from the Peruvian Amazon, Senor Encarnacia, who is a collector of one of the most valuable non-timber forest products that are traded globally on our planet, the Brazil nut, which is abundant in Peruvian Amazon, including Brazil and Bolivia. But in the Amazonian region of Peru, here, particularly in the Madre de Dios region, here you can see it borders on Brazil and Bolivia. You can see where it is located here. Is a global biodiversity hotspot with extraordinary endemic diversity that is faced with major land degradation as a consequence of illegal logging and conversion of forests to agricultural land, particularly grazing and for monocultural agricultural practices. So this area is increasingly threatened by land conversion, and the Brazil nuts offer a significant opportunity for livelihood generation through the maintenance of trees in landscapes. Just to give you the scale of these trees, I don't know if you can see here, but actually in the very bottom of this tree, I'm standing next to the tree. So if I zoom in here, you can see the scale, but these are towering giants of the Amazon going up to 50 or 60 meters tall. And so have a huge potential for sequestration of carbon and locking carbon in, and are legally protected in Peru, and significant up to 70% of the annual income generation of harvesters who collect these from wild populations of this species. The seeds are highly nutritious. They have the highest selenium content of any consumable plant. They have multiple uses, can be used in the cosmetic industry with byproducts, can even be used to brew beer and other beverages, and so offer a very resilient livelihood option for local communities, with international trade being in the billions of dollars. And so in a project which we ran through the ETH Zurich, we were looking at the sustainability of this value chain, and I just want to highlight a couple of very interesting studies. First, this one was led by Gabriela Vidaquera, who was a master's student working with me, and then went on to become a colleague at the Biodiversity International, where she was looking at the pollination services in degraded forests of this particular species of tree, the Brazil nut, and looking for the first time at what actually the pollinators are and how land degradation impacts pollinator visitation. And what this figure here basically shows you is that a single species of Xylocopa is by far the most important species for pollination of this species of tree. And this is a species that actually requires standing dead wood for its nest sites. And so this project also looked at how one can develop artificial nesting habitat to improve degraded forest for maintaining pollinator services. And you can see here that in these nests, we had 100% colonization of these pollinators within these nests. So this study not only understood ecology, but also how we can start to be adaptive in the management of these forests to maintain these pollination services. And I'll just flag here also that we published last year an FAO working paper on the role of pollination services from forests for agriculture and surrounding landscapes. And this is another critical role of tree biodiversity in production through delivering these pollination services, because they're so important not only in the foraging of pollinators, but also in nest sites. A second study within this frame of this Brazil nut work was looking at the economics of implementing agroforestry as part of restoration of these degraded lands in Peru. And Elisabetta Langro was a master's student, again working here, who conducted a very nice economic analysis looking at the different profitability of different land uses. And the only thing I really want to highlight from this study that was published last year is that actually converting to multi-polycultural agroforestry systems using indigenous fruit tree species is a far more economic activity than looking at monoculture or single agricultural crop species that are typically used at the moment. So from an economic point of view, using that native tree diversity is a much more beneficial use of agriculture, agroforestry land, rather And the major barriers to this are not economic, but actually understanding and appreciating the value of that native fruit tree diversity. The third point I want to make within this case study was actually work we did where we looked at the role of trees in improving diet diversity. And just to very simply summarize this work, which was published again in 2020, it shows that using household surveys of diet diversity and nutritional equivalent ratios of food intake for different communities across 7 countries and 5,000 rural households, that trees have a very, very significant role in delivering certain types of nutrition. Up to 30% of vitamin A and C intake are delivered by foods consumed from trees locally. And tree-based foods can provide up to 4 times more vitamin C and 9 times more vitamin A compared to other staple crops or other commodities. So the nutritional importance of trees is also a hugely important component. So in addition to that kind of value chains associated with consumption, there's also another opportunity related to tree genetic resources, and that's related more to the value of those species. And I very briefly just want to mention some work that we've been conducting in Cambodia in collaboration with the University of Oxford through a UK Darwin Initiative project, which was really looking at value chains related to seeds and seedlings of high-value rosewood trees. And rosewood, if you're not familiar with it, in the genus Dalbergia, is one of the most economically valuable CITES protected species within Southeast Asia, particularly used in the furniture manufacture and even jewelry, because of the high value and the fragrance of the wood. And so we were looking here at diversifying livelihoods for high-value rosewood species within context of Cambodia, and looking at different locations across this area, and particularly looking at how farmers can use genetic resources as a diversification for their livelihood options. And here this farmer is Mr. Sok M started a small entrepreneurial exercise where he was looking at supplying seeds of rosewood, particularly Dalbergia cochinensis, and a few other species, and collecting these from wild trees surrounding his farm, and then propagating these within a nursery, and then looking to sell these for restoration activities. And what's amazing about this was a nursery that he initially established, and then through the Darwin Initiative project, we were able to support with some improvement to the nursery in 2020. And what's incredible about this is if you look at the actual economics of the value of these resources. So here is the values of the species and the weights that he could generate from a single nursery. That's 25 kilos of seed for Dalbergia conscientis, which has a market value of $150 US per kilo, and the potential to produce 100,000 seedlings in a year with a value of 25 cents per seedling through these kind of nursery activities. So if you look at the total sum annual income from that, that's a total of nearly $5,800 through these different species through seed collection alone. And then if you cultivate those into seedlings, you can generate up to $25,000 from a single nursery for some of these very high value tree species. So there's a huge potential for sustainable livelihood options using these very valuable tree genetic resources that can be cultivated and then used for restoring, many of which are very threatened species. But is there a demand really for these kind of entrepreneurial activities? Well, we know there are 2 billion hectares of degraded land globally. We have the Bonn challenges with 57 countries and 350 million hectares committed for restoration by 2030. Within Latin America, we have the 2020 initiative, and within Africa, we have the 100 million hectares initiative, where many countries have committed to restoration by 2030. So there is a huge political ambition, which is represented also by the fact that we're now in the third year of the decade of UN Decade of Ecosystem Restoration, and a global commitment to deliver about 1 trillion more trees to the planet through different restoration activities. So there's a huge political demand, and the question really arises, is there the capacity to deliver these different restoration commitments? So I want to pause quickly there. I've been talking already for nearly 25 minutes, just to have a break in my lecture and to see if there are any immediate responses or questions, and then I'll follow on with a bit more of the work that we're doing to address these issues.
Question? Yeah, is there anyone who would like to interact with Dr. Chris? There is a question, one question here in Q&A. Dr. Chris, how to fast track tree improvement of indigenous species, especially for Pterocarpus santallanus, Malaina arborea, Dalbergia shishu, Acacia nilotica for deliberate incorporation in agroforestry system?
Yep. Okay, great. I mean, I'm going to talk in a bit more detail generally about this in the next half, but maybe just to give my first issues on this. I think there's two components to this. One is about selecting plush trees and really looking at improving the material that's used in agroforestry systems through verification and documentation and tracking of seed quality. And the second is about all of the technological opportunities there are there for looking at improved breeding and selection of germplasm through things like marker-aided selection or progeny trials, assisted migration, adaptive migration kind of strategies to different tree species. And I think applying those technologies can be very useful, but I also personally have concerns about maintaining genetic diversity at the individual and the species level in agroforestry through maintaining high diversity germplasm. And of course, when we look to improvement, we typically look at things like looking for clonal production of high yielding, high quality material that ultimately contributes to some of the similar problems we have with monoculture and more industrial approaches to agriculture. And so I think there's trade-offs there between improving domestication, improved varieties, and reducing overall genetic diversity of things like pest and disease resilience and climate adaptation. So I will talk more in detail about some of the work we're doing in the next half, so I won't say more now.
Okay. Thank you, Dr. Chris. So anyone else from the participants who would like to interact on the lectures, on the activities in which biodiversity has been involved? I think I have a question, but that's just like a follow-up of the previous question. So I'll ask you as and when you have sort of.
Okay. I mean, if there's no other questions and we don't need to pause, I can continue. I just thought it was nice to break up for people to not be overwhelmed by too long a lecture.
Okay. I think there's no other query. Yeah, I think Dr. Chris, you can continue.
Okay, so you can still see my slides, right?
Yeah.
Okay, great. Okay, so what I want to do now is to continue on this thread and really talk a little bit about the central role of tree biodiversity in decarbonizing food systems, enhancing biodiversity in production landscapes, enhancing adaptation and resilience to climate change, and diversifying sustainable options for rural communities. And we actually published a paper in People and Nature in 2020, which I'm just flagging here, which I think is a really nice overview of these different topics, particularly the opportunities, but want to flag that there are a number of challenges with delivering on that potential. And this is what I want to, our team at the Alliance of Biodiversity and CIAT have really focused on. And so the team that I work with across the Alliance is a very interdisciplinary team, which includes spatial analysts, ecologists, geneticists, gender specialists, and nutritionists. And we work across Latin America, Africa, and Southeast Asia, including with colleagues based in India, particularly Prem Mathur and Smita Krishnan, and colleagues in Southeast Asia, Reena Janal and Tanya and Naraka. And I think there are some major challenges with delivery of these benefits from tree species, and these particularly orient around some information about the genetic quality and diversity of material that's used, the diversity that is used at the above species level, so the number of indigenous species that are used or native species, the ability of those species to deliver value chains, and the delivery of those species, the potential of those species to deliver on biodiversity benefits. So within the Alliance of Biodiversity and SEAT, we've been championing a concept called Trees for Seeds initiative, which was really about how we can address these issues of land degradation and by the right tree species and the right quality of tree seeds for the right place in the context of restoration. We have three main areas that we work within. The first is about safeguarding for sustainable use, because if we do not conserve the genetic resources of native tree species in their natural habitat, we do not have the capacity to use that diversity for more resilient landscapes. The second is really diversity to deliver multiple objectives. So that's understanding how those different tree species will deliver climate mitigation, water improvement or soil health, biodiversity benefits, and livelihood options. And the third is about ensuring locally adapted materials. So that's making sure that the species or the genotypes that are used in restoration are really the most suitably adapted for local context. And so I want to talk a bit about some of the work we're doing within the frame of those three different activities. And the first of which is a project that was called Abforgis, the Asian Pacific Forest Genetic Resource Information System, that was really looking at how we can conserve better and deliver the genetic resources across multiple Southeast Asian countries for delivering on restoration. And just to remind you of the scale of that challenge, there's about 19,000 native trees across the region of Southeast Asia. So we've got some extraordinary challenges in terms of the conservation across all of those species. And we also have 4.5 billion people across this region. I think that's the right metric. So we've got this challenge both at the species of tree level, but also the pressure on this land. And so we started this work in 2018. It's a collaboration between 14 countries in Southeast Asia, including India, were participants in this work. And it was led by our network, the Abforgis network, which is really how we've been addressing this issue of tree safeguarding resources by convening regional networks of experts and stakeholders interested in forest genetic resources. We have the Latin American Forest Genetic Resource Network, FLAFORGEN, the Sub-Saharan African Forest Genetic Resource Network, SAFORGEN, and the Abforgis Asian Pacific Forest Genetic Resource Network, all of which have been working really to collect information collectively and then use that spatially explicit understanding of species distribution and combining that with threat data, land use cover, climate data, overexploitation, and looking at developing maps that can enable us to set priorities for conservation of different species across different scales in the context of both climate change and land use. And so this first slide was for a specific species of cherimoya. The second here is for 16 nutritionally important food trees across Burkina Faso in West Africa. And this final slide shows you hotspots of in situ conservation for 69 native tree species across 14 countries in Southeast Asia, where we were looking at how we can help to set spatially explicit priorities for both conservation in situ and restoration for those species that need to be conserved either ex situ or through restoration. And this work is also platformed within a platform called Tree Diversity. You can look at the website there. And we conducted an analysis of 69 species that was published in the journal Conservation Biology just at the end of the last year and led by my colleague Hannes Geisberger. And what I want to highlight from this recent analysis is two things. First of all, that many of these tree species are not covered by national protected area networks, so they don't fall within areas which are automatically conserved by national strategies, but actually occur in production landscapes. And so there's a critical role in conserving these genetic resources through integrating conservation into agriculture. And the second point, which is illustrated very nicely by the threatened analysis species analysis of these vulnerable species, Afzelia zylocarpa, is that what this shows you is that this species vulnerability is transcending national boundaries. So there's a real need for collaboration across countries to enable conservation of these species across different, because in the face of climate change, national borders are not relevant, but actually the species, how the species distribution will change in the face of climate change is independent of political boundaries. So we really need to have these regional strategies of conservation working collectively across countries to make sure these species are conserved. The second topic I want to mention is about the capacity of countries to actually deliver quality seed for restoration or agroforestry practices. And this is work that was conducted by Enya Bossard, who was a bachelor's and then a master's student with me at ETH Zurich. And we published at the end of last year a paper that really looked at how fit for purpose seed systems were in 4 Asian countries, including India, Malaysia, Indonesia, and the Philippines. And this was co-authored with a number of colleagues from Indian institutions, including the Indian Center for Tree Genetic Resources. And what I'm going to skip through these slides because I've already highlighted these points. But one point I want to make is that we know from previous work that restoration very often fails because of a lack of consideration of the genetic diversity and quality of seed or seedlings that are used in restoration. And so this study, which combined a literature review as well as interviews from key stakeholders across these 4 countries, is placed in the context of substantial restoration commitments. There's a national restoration commitment of 26 million hectares by 2030 in India, 14 million hectares by 2030 in Indonesia, and 7 million in Philippines, and 100 million trees by 2025 in Malaysia, which could contribute to about 13% of the global bond challenge goal, but it's going to require, we estimate, around 157 billion seeds and seedlings if it's going to deliver on these restoration commitments. So are these countries really able to deliver these seeds and seedlings to meet these commitments? And so we combined using a methodology that was established by colleagues for Latin American countries, an analysis of the seed systems, both national, formal and informal seed systems, their ability to select for seed selection and innovation, for seed harvesting production, the market access and supply and demand, the quality control, and the enabling environment for delivering good quality seed across these 4 countries. And at the national level, the methodology uses is based on a paper that we published in 2018, which was really based on Latin America, but it looks at a whole range of different aspects of the seed system and then evaluates a country's capacity to do that based on things like the genetic data that define seed zones, information availability of stakeholders, standards applied for genetics quality, or standards for applied seed sourcing and harvesting. And if we look at, so this is just to highlight the work that was done in Latin America, and you can see here there's very distinct differences in the capacity at the national level to deliver seed quality within these 7 Latin American countries. And the one thing I want to highlight from the Latin American study is that in all cases, if you look at this table here, it shows you the number of species that are native to each of those countries, and then the number of progeny trials or improvement varieties that are available for each of those species. So there's a massive distinction between the local biodiversity available in terms of forest species and those that are then put through improvement or available in seed systems for quality. We're talking only tens of species out of thousands of species. So if we look in the context of the Asian countries, we can see that the countries vary also in their national seed systems, which we would argue in all 4 countries are really in a rather embryonic state, given the huge commitments that have been made at the national scale. And none of the countries really have a full suite of the capacities to deliver at scale high volumes of high diversity of native species and quality seeds or seedlings. So the conclusions from that study really were that the key areas for improvement are better exchange of experience among different seed system stakeholders, particularly in the context of among countries, but also the overarching challenges of propagation and seed sourcing, and building on experience from other subsectors. So that might be from crop seed systems, and improve linkage between forestry and agricultural sectors for tree seed system improvement. And particularly to collaborate for challenging species, so that particularly in the context of threatened species or the many recalcitrant tree species that one can't store seed for long periods of time. And this is a key challenge with scaling seed systems for many tropical native tree species. And then improving information flow, particularly through digital tools, such as smartphones and web-based applications. So I want to now talk about how we've been trying to address these problems through some of the work we're doing with capacity building and development, and particularly introduce to you a tool that we developed called Diversity for Restoration, which is an open source decision support tool, which is spatially explicit to enable any restoration or agroforestry practitioner to be able to input information into a platform, such as their objectives in terms of livelihood generation, food security, sorry, my slides, food security, biodiversity improvement, soil health. And then the platform will actually give you a list of native tree species which are most suitably adapted to that location. And in addition to that, includes climate models and seed zoning, which enables you to identify where the seed sources could be that would be most suitably adapted from that species for your restoration sites. And this methodology was published in 2020 in Global Change Biology. And we've been integrating with this approach inclusion of nutritional information from different native tree species, including not only nutritional profiling of the fruits or other products from the tree species that may be important for human or animal consumption, and looking at diet diversity across the year. So how you can increase the range of products over a total annual calendar to improve food security through the inclusion of more native trees diversity. This work was conducted in Burkina Faso, Cameroon, and Peru and Ecuador, so integrated within the Diversity for Restoration tool. We're also applying the same methodology to agroforestry systems specifically. So in addition to restoration, how you can improve the use of different native tree species within different agroforestry systems, including coffee production systems, and in this example here, particularly in cacao production systems in Latin America, in Peru and Ecuador, and through the selection of native tree species that match agroforestry objectives, and particularly linked to climate change impacts that are likely to threaten the commodity side of the agroforestry, so how climate change is going to impact on cocoa or coffee. And we're in the early stages now of developing similar work for working in the Western Ghats in India in the context of coffee production systems. I just want to briefly mention the economics of integration of genetic diversity into restoration, and some work that we published in 2021 that really looked at the costs of improving the integration of genetic diversity using a rather an economic lens to understand what are the implications of integrating genetic diversity better into seed systems, into planting, and into restoration. And the key messages from that really delivery through improved seed systems to meet restoration commitments and local needs, we need to have genetic diversity at the basis. And this has a potential to de-risk investment through use of adapted and optimal tree species choice, and ensuring efficient investment through cost-effective intervention. So this study actually basically shows that from an economic point of view, it's completely a no-brainer in terms of integration of genetic diversity, because the cost of doing it is far less than the negative effects of failing to integrate genetic diversity through poor survival, the cost of replanting, or the additional activities that are required for remedying the negative effects of failure to include a locally adapted material and genetically diverse material. So I want to also think about the actual practicalities of seed systems, and in the context of native trees, where many of the seed sources will come from wild tree stands, there's a real need for innovation in tools to support seed collection for genetically diverse material. And this includes not only understanding exactly what species you are collecting from, but also how many individuals contribute to a seed collection, where that seed trees are, what the environment of those seed trees are, and then enabling us to collate all of that information into a single simple platform. So we delivered a tool called Seedit, which is a mobile phone application, which enables you to do exactly this, to track the origin of seed and the genetic diversity through the number of mother trees contributing to a seed lot, and enable us to improve documentation and verification of seed quality used in restoration activities. And this work is now currently being implemented in a project in Cameroon and Kenya, which is supported by the Global Environment Facility. It's a 3-year program of work that we're just starting in the next month, which will combine both the Diversity for Restoration tool and the Seedit app to incentivize farmers to increase trees on farm, not only by building their capacity to integrate trees into systems through restoration monitoring, but also with linking this information to, for example, carbon financing, so farmers can monitor and evaluate the trees they increase on their farm, and then receive payments directly through mobile phone, not only for the planting, but also for the carbon that those trees start to accumulate on farm. And combined with this, of course, we need to think about innovations in value chains, so improving the farmer's capacity to build entrepreneurial value chains for many non-timber forest products. And there's a huge opportunity with indigenous fruit and nut varieties to do this work. Within the context of this work, we're combining the diversity for restoration, the seed as I say, into the Restoration Grand Challenge platform, which will also have a crowdfunding component, so that this information is all stored through a blockchain platform that enables a completely transparent and verifiable method of payments to farmers and linkage to any form of investment using the most suitable indigenous and native trees. Finally, I just want to introduce another initiative that we're just starting specifically in India, which is called Fruitful India, which is a collaboration across multiple research centres in India and hosted by the Alliance of Biodiversity in SIA, with a vision to increase access to nutritional fruit across urban and rural communities, especially to improve the diet diversity for children, and laying the foundations of a virtual knowledge resource hub, which will be called Fruitful India, which ultimately leads to nutritional security through sustainable fruit tree cultivation. So it's a partnership between the Alliance and national universities, including ICAR and regional universities, that we had an initial donation of $650,000 over 2 years, and a total commitment of over 10 years of $10 million for this initiative. And initially includes, we'll have 6 national PhD students, which will be jointly supervised across centres. And the theory of change around Fruitful India is really about addressing this issue of children with poor access to nutritional diverse fruits. And in the first phase, which is in the lower circle here, to increase capacity to produce nutritious native fruit tree species and increasing awareness of their benefits. And then going through into the second phase, which will be about increasing production of these native trees and understanding the benefits to biodiversity, but also the benefits to climate mitigation, and increasing affordability and equitable access to nutritious fruit, particularly in these stakeholder groups in rural environments. And ultimately, the aim of Fruitful India is that nutritious and diverse fruits are widely available and consumed as well. So this is not only about increasing production, but increasing an appreciation and awareness. And we'll be working with school feeding programs and including demonstration school fruit tree orchards as part of the long-term vision of Fruitful India. So I want to wrap up. I've said a lot. I've talked about a lot of different initiatives which we are working on, but can we really bring 1 trillion trees back to our planet, as I started at the beginning of my lecture? And I think we have some real challenges. Particularly, we currently lack the capacity and the infrastructure to deliver native trees at scale in most developing countries. And this is a problem that we really need to address, not only by improved knowledge exchange, but also investment in those countries' capacity to deliver that biodiversity. In many, it's focused on exotics or commercial species and not on native diversity. We have a limited evidence on the value of trees to deliver multiple sustainable development goals, although the potential is enormous. So really linking our scientific evidence base to show that we can sustainably produce more tree-based products without costing water or with improving the benefits of soil, but also improving the biodiversity benefits of integration of those species. And we need a substantial investment to scale impact, but the potential economic returns on that are huge, as I've illustrated through the entrepreneurial opportunities of sustainable trading of forest genetic resources. So I would finally just like to highlight that I think forest genetic resource biodiversity is absolutely critical to resilient futures. It's at the foundation of climate mitigation, but also transitioning to more sustainable diets, both consumption and production. And from my perspective, tree biodiversity offers huge opportunities, but we really need to conserve that tree biodiversity in its natural environment to be able to use it to its full potential. I'll share with you the references from today's presentation, but like to thank everyone for their attention, and I really hope this has been a useful exchange of information, and I'm very happy to connect with anyone. Please send me an email, reach out to me if you want to have any further information or to discuss in more detail. And I'll stop sharing.
Okay, thank you, Dr. Chris. And I think the chat box is full of the appreciation and the lecture which you've given. It's very informative and interesting. So there are lots of comments on the chat box. So now I invite the house for the participants to, if you have any queries and clarifications regarding the lecture, you're free to question them, to ask. And after I will go to the Q&A. Okay, first of all, the participants, if they have any queries.
I see there's a few questions in the chat already.
Yeah.
Well.
Okay. And let's just take first from the people who are online. I mean, who can.
Sure.
So anyone who wishes to hear their doubts regarding the lecture. So, okay, I have a doubt, but let's go first to the Q&A first. Okay. Yeah. Oh, there is one from Nina Kumari. So from the presentation, it seems that much of the work has been on the tropical areas. So does the organization also has its the experimental sites in the temperate areas? Because even agroforestry is an important component there in the temperate zones.
Yeah. So maybe just a quick response to that. I mean, as an organization, the Alliance of Biodiversity International has a mandate to work in tropical countries and in developing countries as well. So our work is research for development. So we're not working in temperate regions really very much. I mean, we've done some work in Central Asia, which is more temperate, particularly on apricots and walnut. And so we've looked at the genetic resource base for walnut and apricot and also a lot of work on fruit trees in that part of the world. But our mandate really is on tropical systems. And just to add as well, we also have had a long-standing collaboration with the European Forest Genetic Resource Network, U4Gen, which used to be hosted by the Alliance of Biodiversity, and we continue to exchange with them and have a very useful exchange between the European context of forest genetic resources and the tropical countries that we're focused on. So I guess that's but we're not doing experimental work in temperate regions.
Okay, thank you. There's another question. The question is from Lingaraj Sarjan. The question is, planting of bamboos in parts of India, will there be any change in the biodiversity?
Okay, I mean, I can comment on this. It's really not my area of expertise, but what I know for bamboo is that it really depends on the species of bamboo that you're planting, because some bamboo can be incredibly invasive. And so if you start to include planting of bamboo that becomes invasive, that of course will lead to a competition with native species diversity and can be very outcompeting. So bamboo can also be very water demanding. It's and very hard to control once it's in, but although it can be a very powerful restoration tool if the right species and in the right context. So it can generate fiber, for example, very quickly, and so can be in certain types of restoration useful. Yeah.
So okay, any other question? So there's none, then I would like to clarify one doubt. So in the first question which we have asked is on tree improvement, how to fast track. So there's a lots of, I mean, if we need to maintain the biodiversity, there'll be lots of different species which are required to be maintained in a particular landscape. Now, do you see any prospect of improvement of so many species? Would you think it'd be a futile exercise to start an improvement program for many species, and up to which level can we sort of devote our funds to improvement of fruit tree species?
Yeah. No, I think that's a great question, and I think, of course, we can't target all species. We have to be pragmatic, and we have to use the limited resources we have strategically. And I think there is scope, and indeed in the presentation, the work I gave you for this Asian Pacific region, we really targeted collectively the 69 species that were most important across those 14 countries, both ecologically, economically, socially. And so these are actually widespread species. Some of them, for example, things like jackfruit and durian, which that have high economic value, but the genetic resource base is not well conserved. So even those species that have a very high economic value, we need to set priorities on so that we can conserve the genetic resource base, but also select for improvement that it, through different, for example, provenance trials and integration of molecular approaches for selection of different varieties. So I think we have to be pragmatic. We can't possibly have improvement programs for every single native fruit tree, and I don't think we need to. I think actually including well selected and seed sources from many wild populations of certain fruit tree species could have many benefits. And what we can do is we can start to integrate, using technologies, strategies for selection through restoration. So, for example, we've been implementing in crop wild relatives and other crops something called tricot, using a CLIMOB application, where farmers are doing their own breeding, selection and trials for crop species. And one opportunity would be to integrate those technologies with trees on farms so that we can actually do selective improvement during the restoration process. So we start to monitor and evaluate which genotypes are most beneficial, are delivering the most production, delivering the most benefits, and then start to target those sources for additional use and selection.
Thank you, Dr. Does anyone have any query? So before we end the session, I'd like to invite the coordinator of the center and head of the Environmental Science Department of Mizoram University, Professor O.P. Tripathi, to propose the vote of thanks. Sir.
Dr. Lindo.
Yes, sir.
First, thanks to you for organizing such an informative and valuable webinar series in the Mizoram University. So thanks, Dr. Lindo. Very good afternoon to one and all. On behalf of Mizoram University, I take this opportunity to propose the vote of thanks, who have directly and indirectly made this program a success one. On the webinar on exploring the role of tree biodiversity in resilient agroforestry landscapes, organized by the Mizoram University. So first of all, I thank our distinguished resource person, Dr. Christopher Tetley, Principal Scientist and Global Program Leader, Tree Biodiversity for Resilient Landscape Alliance of Biodiversity International, Switzerland. We are really enlightened with the depth of knowledge that has been shared by our resource person. So I am very confident that all the participants and the audience has been widely benefited by this deliberations. So thank you very much, sir. Dr. Christopher, thank you very much. I also thank on behalf of the organizing committee to our Honorable Vice Chancellor, Dr. K.R.S. Sambasiva Rao, for his constant encouragement, suggestions, and for organizing all these programs and extending all the logistic support to make the webinar series successful. I am also thankful to our administrators, Registrar of the Mizoram University, Finance Officer, System Administrator of ICT Cell, Mr. Suraj, for making this program a great success one. I am very much thankful to all the faculty colleagues of Mizoram University who had participated in this program so that our participation could reach more than 120 or so. Although parallelly we have one more program going on the Biodiversity Day celebration because we could not celebrate on 22nd. So university is also hosting with our Honorable Minister of Environment and Forest and Climate Change in the university. But in spite of that also, lot of audience. That is just because of the theme of the Dr. Christopher. So I thank all my faculty colleagues and staff to make this. I cannot thank one and all. I cannot thank each and everyone who has directly or indirectly made this program successful. But we from organizing committee thank one and all. Thank you very much. Thank you. Thank you, Dr. Lindo.
Yeah. Okay, Dr. Chris, thank you so much again.
Very welcome.
We'll keep in touch and
definitely. Yeah. No, great. Thanks very much for the opportunity and great to connect. And yeah, as I say, feel free to reach out to me in the future.
Yeah. Okay. Thanks. Thank you. Bye bye. Please do conduct more program. These